All right, angle bisectors. And I apologize about that first scan there. Not great, but I don't know if you want to kind of roughly sketch that. I wouldn't worry about being super duper precise, but basically you're going to see a lot of this today, okay? They're going to present you with angles, all right? So for instance, right here, and let me pencil this in. That angle FEG, okay? FEG, that's that big angle here. FEG, that angle, they have bisected. They have bisected that angle with that line EP, okay? That's kind of what you're looking at there, all right? And with EP being an angle bisector, it splits that angle into two equal parts, which they have denoted by a 1 and a 2. So angle 1 and angle 2 are congruent, okay? They are going to be the same. And again, this is going to be a reoccurring theme in these pictures, all right? What's going to vary problem to problem is going to be the information that they are providing you about the picture. You know, did they give me one of the angles? Did they give me the big angle? How did they present the angles? Those types of things. So right here, they want us to find the measure of angle 1 if the measure of angle 2 is 25 degrees. Well, if that line truly has bisected that angle into two equal parts, if angle 2 is 25, then what's angle 1? 25. I mean, it's, you know, we're starting very simple here, but that's the idea, okay? So if they give you an angle measure, we're simply going to match it. If they wanted to know what the full angle was, what was FEG, the big angle itself altogether would have been 50, if they wanted to know that, okay? So again, kind of goes back to what they want to know, but once we have certain information, we can give them a lot of things, okay? So very, very basic there. Does everybody have what they need off this one? Like I said, I don't know if I'd worry about trying to jot down all the little details about it, but I think you'll catch on here pretty quick. Okay, next one. Find the measure of angle ACB. So ACB is the big angle, okay? So this time they're wanting us to find the entire angle, kind of what we just talked about. They tell us the measure of angle 2, which is 31. And again, they have told you in the directions that you've got a bisected angle here. So if angle 2 is 31, what's the measure of angle 1? 31, which then makes the big angle 62 degrees. Okay? Everybody good with that? Pretty basic. Like I said, if they're giving us numbers for these angles, it's real easy. All right? There you go. There you go. We're good. We're good. Got plenty of time. No worries. Are you dying? Go fast. Go fast, big guy. And guys, while we're still kind of right here, Wells, what do you got? Okay, guys, and again, I think I'm stating the obvious here, but with these angles, like angle ACB, that middle letter, like the letter C, that's always going to be the vertex. That's going to be the point at which the two lines create that angle, so to speak. Okay, so just little things about the notation of these angles. Okay, good. Okay, let's go to another one. Oh, you want me to go back? Measure of angle HFG. So again, HFG, we're talking about the large angle here. So this entire angle they're telling us is 30 degrees. And if they want to know the measure of angle 1, if we bisect the 30-degree angle, measure of angle 1 should be 15. Measure of angle 2 should also be 15. Okay? So a lot of it's just going to be, what did they give me? Okay? Did they give me one of the smaller angles? Did they give me the large angle? And as long as they're giving us numbers, not too shabby. And again, if you notice the letter F, F is the vertex with which those two lines create that angle, HFG. And we can name it HFG or we can name it GFH. Either way, one way or the other, but that F needs to be in the middle. Okay? You know what was up there. All right, here we go. All right, let's roll back in a little algebra. Find x if the measure of angle 1 equals 4x plus 3, measure of angle 2 equals 3x plus 7. So the measure of angle 1, 4x plus 3, measure of angle 2, 3x plus 7. If those two angles are result of a bisector and they are the same, what are you going to do with these two expressions? Set them equal to each other. 4x plus 3 should equal 3x plus 7. Little equation, variables on both sides. Again, guys, doesn't matter. Whatever side you want your variables on, you do you. If it was me, I'd probably move the 3x. I like to try to keep my variables positive when I can. 4x minus 3x is 1x. Plus 3 equals 7. Last step to solve. Subtract 3. Boom. X equals 4. Okay? If they want to know angle measures, we can take the 4, we can plug it back in. They just wanted to know x. We gave them x. But if they want to know angle measures, we go plug it back in. 4 times 4 is 16. 16 plus 3 is 19. 4 times 3 is 12. 12 plus 7 is 19. So that would check out. These things are indeed equal. The angle measures would indeed be equal if they want to know that. So we can always check that kind of stuff. Okay? Everybody good with that? You know, things that I saw the last, Monday, Tuesday with doing equations like this is, and again, in general terms, we've still got a lot of students that need work solving equations, especially with variables on both sides. We've got people that are taking things to sides that shouldn't be taking things to sides, and it's kind of mathematically illegal things, and it's causing sign problems, and so just keep working with the equations. All right, here we go. Another variation. I think this is the last one. Find x if the measure of angle 1, so angle 1 right in here is going to be 6x minus 1, and RTS, so the large angle, this whole thing is 10x plus 4. This is similar to one we did with the segments the other day. We know the entire angle. We know one of the angles. Both of them are represented with algebraic expressions. What do you think? Can we set 10x plus 4 equal to 6x minus 1? Would those two things be the same thing? No. It wouldn't be, right? How many angle 1s would it take to make both angles? It would take 2. And we kind of had a problem similar to that the other day. Say, look, we've got angle 1 with 6x minus 1. Gosh, if we had 2 of those, that would equal the whole thing. So we can take 2 times 6x minus 1. Let's get 2 of those angle 1s. And let's set it equal to the entire angle, 10x plus 4. Little bit of distribution, 12x minus 2, 10x plus 4. Oop. I was trying to move that a little bit. I'm going to take 10x to the left. I'm going to subtract it. So 2x minus 2 equals 4. Add 2. 2x equals 6. So x will be? What's x going to be? Tree. And what they want us to find? They want us to find x. We found x. They want angle measures, plug it in, go find them an angle measure. What would the angle measure be? That'd be 6 times 3, 18. 18 minus 1 is 17. So one angle would be 17. Both angles together would be 34. If they want to know that. Okay? So, like I said, the nice thing about today is you're going to get a lot of pictures right out the gate. So you'll be seeing it right away. You don't have to create anything. You know, it's all right there in front of you. So bless you. Okay? Just pay attention to your given information. Did they give me one angle? Did they give me the full angle? What do they want me to find? Those types of things. Guys, pretty simple. Pretty simple stuff. It